All right, let me check. Any questions about another example using geometry? Well, I assume no. If yes, of course, you can let me know. So after now, we finished the discussion for activity 1, activity 2, and right now we can have the family of distribution. We have the parameter, and later we want to check everything's okay with the current choice. I mean, we have a family of distribution. We have the setting for the parameter. So everything's okay. This is activity 3. Well, activity 3, we have some heuristic procedures. And also we have some tests. And first of all, we have density histogram plots, frequency comparison, difference, and probability plots. Well, this is first one. Continuous data. Then, of course, this is density. And this is histogram. And put them together. Check. Can you accept these? If we have the current density histogram over plot, I think it should be okay, right? PDF actually, this is the PDF you generate, and histogram actually from the samples. Well, why this one? Okay, so think about this. And they should be seamless, of course. Everything will be okay. This is first approach. It's really direct. We just have the overplot and we think everything will be okay. And actually, that is a overplot of density and histogram. And actually, we can change it to frequency. And frequency, in fact, we want to have some histogram, but how to have the histogram? This is a way to have a relative frequency. If we have the interval, we can calculate these. And also, this is a histogram. And put them together, we want to have 2 bars. If we have almost the same, then we can accept. This is the frequency comparison. Even for discrete data, same, we can do so. So, make it simple, the current idea. We can use histogram and PDF. It's really easy. Put them together. So you can check, can you accept if we have the overplot. And the next one, somehow we try to use the density but transform to the relative frequency. Relative frequency similar to the histogram. And so that we can put them together. If we have almost the same, then we will think we can accept those. All right, so this is the frequency comparison. So almost the same, overplot, and frequency comparison. Well, about this, 1 minute to check. Understand? And everything's okay? If everything's okay, then I go to the next one. Next one, we pass on function. Here we have a CDF. And the difference of a CDF. So how to have the plot? First of all, you can have the arithmetic one. Sorry, this is a fitted one. And the empirical one. And empirical one, we have this. And find the difference. So the fitted one, you select a standard distribution. And this one is just a portion. And we will have a difference if a difference is still acceptable. Up to now, for continuous one and for discrete one, it seems to be even we can observe some minor changes, but still, you still think acceptable. So this is the distribution function difference plot. Well, again, allow you to have 1 minute to check everything's okay about this plot. One minute. If any question, raise your hand to let me know. If no, then I will go to the next one. So I assume everything's okay. So let me move on to the next one. Here we have a probability. To have a probability relative plots, we can have a probability directly. So that is called PP plot. Or maybe we don't have the probability. We have the quantile. So we can have a QQ plot. And we can pass on the original fitted one. And here, this is an empirical one. But empirical one, we have a correction. We do not use ratio. We use I minus a half and over the size. So we have the modification. Even you don't think so. If you don't think so, that's fine. You use I over N. And this is a PP plot. To have a PP plot, actually we have a probability, empirical one, probability of a fitted one. So this is called PP plot, okay? And QQ plot, actually QQ plot, you can think you should have a Q and a Q. So we have two Qs, but we use inverse function. All right, so that's why inverse function. And if so, the inverse function, we have a QQ plot. But theoretically, we can treat. Given the probability, we'll find a corresponding quantile. So we have a quantile from the empirical one, quantile from the physical one. And then setting the same probability, we can find the corresponding quantile. And then the quantiles forms the pair. And to have the plot, then we have a QQ plot. All right, this is PP plot and QQ plot. About the ideas, you can check it. Same for 1 minute. And later we can have the way to show the results using PP and QQ plots.